Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. I'm your host, Matt Picardal, and in this episode, I'll be talking with Santosh Vangala, PE structural engineer at AECOM, about the transformative impact of programming in structural design, the importance of mastering engineering software early in one's career, and the future direction of the structural engineering industry. Let's jump into this week's conversation. Santosh, can you start by telling us a little bit about yourself and your career journey and your journey into the field of structural engineering?
Yeah. So I'm Santosh Vangala. I grew up in India and I was there until I was 24. And growing up in a developing country, I was in the midst of all the development that was happening. I was seeing all the roads being laid, buildings being built. I was also very passionate about math and physics growing up. So I just wanted to find something where I could combine my shared interest of math and physics with what was going on. And that's how I got into the field of engineering, not primarily structural, but the more I delved into it, I figured out that structural is a better fit for me. As I said, growing up, you always see buildings like Eiffel Tower and then Leaning Tower of Pisa leaning, and that kind of fascinated me. And that's how I chose structural engineering. And I did my bachelor's in India from IIT BHU, and then spent a couple of years there trying to gain some field experience, and realized that field was not for me. And I wanted to learn more about design and try to design some cool stuff. That's how I got into a master's program and then moved to the US about in 2012. And since then, after graduating with a master's degree, I've just been trying to work on anything that's challenging. And sometimes, if it's not challenging, just try to find something which kind of interests me. So that's a really long answer of how I got into it.
Yeah, that's really cool. What were some of the challenging projects that you've worked on that was pretty fulfilling?
I think there's a lot of challenges on every project we work on, but the biggest challenge, not necessarily from a technical standpoint, but from a management standpoint, was a couple of years ago, I was working under my supervisor, who was the EOR on that project, and due to some change in scenario, he just had to leave the company. And all of a sudden, I was in the midst of handling this project with some prior experience, but I never was in a situation like that. And that's when I realized there's a lot of scope creep items and there's a lot of coordination items. And without having the guidance of someone, it was a little kind of challenging to approach that. I did look at it like an opportunity more than a challenge because, I think that those are the opportunities where you can grow. And biggest thing I learned was if you don't have a lot of experience managing a project, or you're just new, or you're just thrust onto the scene, because you can't plan for those things. And basically there was a lot of lessons learned in terms of how to handle scope creep and just do a lot of coordination with other trades. So that was the most challenging aspect that I ever encountered in my life.
Yeah, something similar happened to me as well during my career. Yeah, similar case too. One of the engineers leaves, or one of the senior engineers leaves, and you're kind of the engineer that's left with the project. And But like you were saying, you learn a lot of lessons, because for me, at least, it was getting to learn what the entire design process was, from design all the way to construction.
Mm-hmm.
And then you get to look at the big picture of the project and see all the lessons learned that you could do that. Maybe if there wasn't a big crunch in terms of if the engineer was still there, maybe you wouldn't get to learn all that stuff. But drinking from a fire hose at that time, but you get a lot of water.
Yeah, I agree. I share the same sentiment now. Looking back, it was a little intimidating, but I agree, it was a great learning opportunity.
Yeah, just not something that you want to be in every single day. Okay, let's get this project done. Let's learn from it.
Yeah.
Hopefully.
Yeah.
And I know you also you're into coding and Python, I believe.
Yeah.
Could you tell us more about that and how you've incorporated that into your structural designs?
Sure. I think it's primarily it started with I learned Python for some other reasons where I was just interested in writing a script for like a fantasy Premier League program. But I worked at a firm where they wanted to leverage the automation, the potential of automation. And given that I work in Python and Revit has a lot of like opportunities to write your own scripts, and using Revit APIs, I develop scripts, and which kind of takes away some of these opportunities for like human error or to minimize basically design errors. And the way it works is like if I'm trying to design a foundation, and we're kind of human, like we do make mistakes, but if you write like a script that's automated, and the opportunity to make a mistake is almost non-existent. And so essentially, like when I'm designing something, in Revit, I write some scripts, and I use Revit in conjunction with other software tools to get the reactions. And once I get the reactions for a column or a foundation, the script itself is like, the script has all the process to check like the design and come up with the size of the footing. So I don't have to manually hand calculate or rely on a program to actually do that for me, because once my script has been vetted by several engineers and it's deemed to be correct and appropriate, I can just, with a click of a button in Revit, it can actually like design some stuff without any errors. And it also can save a lot of times by just replicating designs or even like creating views and stuff, which would minimize the process that we take to develop construction drawings. So that's primarily how I use it, to basically like minimize errors, because as humans, we tend to make mistakes, and I just want to protect ourselves, like to avoid doing that.
Yeah, it's like another layer of quality control. Because from the looks of it, it seems like you would do maybe a column load takedown, but instead of doing each and every foundation calc, you have a script that automatically ensures, once it's been vetted and all that, maybe that load is for that specific footing, versus if you were to do it by hand, there's a lot of columns. You might put it in the wrong, you might bookkeep it incorrectly.
Yeah. And that has happened in the past, and that's how I realized it. Like, okay, instead of me checking it 20 times by myself, I'll check it a couple of times and then have Python check it for me once. And that was the primary goal.
Yeah, what were some of the common mistakes that you were seeing that had scripting help mitigate those issues?
Yeah, I think some of the common mistakes I can think of are like, essentially like once we design, transferring all of the design from a software or from your calc into the drawings. That was the major, like that was where like I noticed we make a lot of mistakes, because we have done the design correctly, but to transfer that, you're manually transferring all of that design data into Revit. You have to create like a foundation, like rebar schedule, and then you have to give the rebar and stuff. But because you're manually doing it, you have to be 100% sure that the rebar you're getting from the software is the same as what you're listing it on the drawings. And in addition to that, depth restrictions of the beams. Architects tell me all the time, you cannot have a beam more than 12 inches. I assume that all of the beams are correct, and when I place them, but there's always like a rogue beam which is like deeper than it should be. And so having a script which will just check all of the beams at once and then flags the one which are like deeper. So essentially the biggest error, most of the major errors that I notice are transferring the design items from design into the drawings. And that's where like I feel like Python helped me quite a bit.
Yeah, I think that's a big one, because that's another layer of QC, right? You got to QC the calcs. All right, the calcs are good, the load paths are good, that's the right column. And then now you got to do another QC to transfer to the drawings. And you can see how where the automation helps, right? Because it kind of alleviates some of that. Make sure that it's right, but also saves you a lot of time. And okay, so I'm always curious, because for me, I learned programming like MATLAB and grad school and whatnot, but not so much Python. How do engineers that aren't familiar with Python, for example, how do they get that or start using it at work, or maybe make a program at work to get more people to use it? How did you go about implementing that? And maybe, how do you use it at work, essentially?
So essentially, like, that's actually a wonderful question, because a lot of people like sometimes like feel intimidated by the mention of the word like Python or like a programming language. I would say that that's not true at all. because most of our industry uses Revit and other like these structural analysis softwares, which have these APIs where we can use those APIs to get all the reactions and whatever we want, basically extract data. And Python itself, if you look at it, like it could be intimidating, but if you start with like baby steps, which is like, all I want to do today is just get the foundation reactions. So if you start really small, and in order to actually approach that, the first thing I need to do is I need to open my programming interface and make it talk to Revit or eTabs. That's the first step. And once you like approach that step, there's a lot of like open resources out there. There's like a lot of really good channels out there, PyRevit. And I learned Python, as I said, for different reasons. But if you start writing simple programs to extract data, that kind of gives you confidence. And the more confident you get like in writing a script, it only keeps improving from there, like from thereafter.
Yeah, if you could learn building codes, you can learn Python.
Yeah, yeah, I agree. Building codes, just comprehending building codes can get tricky, but yeah, I agree.
And I'm trying to see how companies can try to implement this more. I think some pushback from companies might be, if you get a script, how do you take care of the back checking of it, the quality control of it? I think you mentioned other engineers could do that to help back check it, similar to a spreadsheet, to make sure that it's doing everything correctly. And what other pushback do you get in terms of if you're trying to do something with a company that no one really knows how to code? And do you try to get more people to code, or do you just try to make it more user-friendly so everybody could use it? What are some approaches do you think that engineers could do?
I think the biggest pushback we get is like sometimes engineers are just, or even architects are intimidated by just the word of using something they're not familiar with. And I can sense that uncertainty that they have, and it's completely valid too. I think one of the ways like we can resolve that, in addition to that QC, instead of writing a script, you can kind of package all of that script into a simple button in Revit. So in Revit, you can create like a custom tab and create a simple, like with a click of a button, it will be something like foundation check. And you just click on it. That's a lot more simpler for people to use. And we can create all of these, like, I would say buttons or in the ribbon, and then we'll package that as like a .msi installer. And once we send that .msi installer across different offices, all they have to do is like double click on it and install it, because it's more of an executable file. And a new ribbon will appear in Revit with all these tools. That way they're less intimidated to use it. They know it's just they can use it at the click of a button, and all they have to do is like use their mouse to get there. But in terms of like how they can get confident about using like what the tool is doing, as I said, there has to be a thorough QC process, and I sometimes notice that doesn't happen. And I'm a big proponent of my code it has to be checked by, if I have 10 different offices, at least one senior engineer in 10 different offices have to have these meetings once a month to check this code and say that, okay, this is correct. This script can be utilized and it will protect us against any liability. And then we can propagate that. So yeah, I still agree that initially you can get a lot of pushback because we need to invest some time to do the QC and to install all of this. But if you make it simpler for them, they're more likely to use it.
Yeah, I like that button where I think you can get the offices more in line with it, or the other engineers, or is it where they have a spreadsheet and you have a button or an executable file, they can see that, and that could save them a lot of time, and then maybe they could get more interested into it, and then that way you can have more people that are able to do QCs on it.
Yeah.
And what about, you mentioned resources. So for engineers that aren't familiar with it, do you have any of them that, off the top of your head, that are just good places to start?
Absolutely.
Or what to Google, or specifically for structural engineering?
Yeah, absolutely. As I said, like I learned Python for different reasons, but I just learned Python with Coursera. Coursera just had like a $49 subscription when I was learning. So they had Introduction to Python 3 Programming by University of Michigan, Ann Arbor, and that course is very comprehensive. So if you're able to finish all of that course, it'll kind of set you up for success. And in terms of, but that's only the first step. You can't just directly use Python to, you can't just learn Python and start using it for your structural engineering software or Revit. The other step would be to learn how to use the APIs for Revit and the APIs for ETABS or other structural software. Revit, there's a fantastic channel on YouTube. It's called PyRevit, and that has at least like 10 different lessons, which kind of guides you to the process of how to use the APIs from Revit using Python or any other programming language for that matter. And similarly...
That's PyRevit?
PyRevit, yes.
P-I...
It's P-Y, P-Y, Revit.
P-Y.
Yeah.
Cool, yeah, I'll look that up too. That one seems cool.
PyRevit.
Oh, go ahead.
Yeah. And for Python, as I said, there are several resources. The one I primarily used was a simple course by University of Michigan on Coursera.
Gotcha. Yeah, I'll recommend those and maybe check those out myself.
Yeah.
Yeah, for me, it's something I've always wanted to learn, and I dabbled in a little bit of it, but haven't taken like a full course or anything. But yeah, it just seems like that's really helpful. I've talked to other engineers similar to yourself where they use it, and it saves them a lot of time. But I think that intimidation factor, right? If we can get over that as an industry, it can help us out.
If it helps, like the way I always give someone a suggestion is, I can do it. I strongly believe like anyone else can do it. So, and I truly mean that, because I don't believe like I hated coding all my life. Like I never wanted to code at all. But then I think you also need someone like to have confidence in you. And then, as I said, it's definitely doable.
And I know you've also been recognized as a top young professional by ENR, the Engineering News Record. Tell us about that.
Yeah, I think like sometimes like the way I approach individual awards is they make you feel good, but they actually don't paint the whole picture, which is it's actually behind the background. There's a lot of great work that's being done by my team. And so it's actually kind of a representation of the great work that my team does. And I'm fortunate to be nominated by one of my team members here. And then in addition to actually like being good at what you do, and I personally feel like being good at what you do is subjective because I constantly feel like I'm learning every day. So I don't want to say that I'm technically good or anything, because I'm a constant work in progress. So you have to be good at what you're doing, or you have to work hard. But in addition to that, I think the biggest contributor like to me getting that award was like, how are you giving back to your community? And how are you contributing back to the civil engineering society? And I would strongly recommend engineers, in addition to like what they do on a day-to-day basis, to try to like use their skills to like volunteer or help kids. Like I used to tutor sixth graders like on math. Basically, it was an on-course STEM program. So I enrolled and I was helping the kids with that. And I try to also actively participate in ASC Young Members Group. And sometimes like we try to do some mentorship programs with high school kids and try to help them out, and then basically try to like extend the whole STEM outreach. So in addition to what I feel like, I sometimes feel like maybe I don't deserve the award, but because there's a lot of brilliant engineers out there. But again, giving back to your community is like something to keenly look at. And it also brings you immense satisfaction, like being stressed out at work. If you go teach a kid, I think that was my way to like, that was my de-stressor. So, yeah, I just feel like I've just been fortunate to be surrounded by a good group of people who believed in me. And also, I was just lucky, I would say, in few words, that I even got that.
Yeah, I think giving back, I think that's a huge thing that probably engineers in the middle of their career don't really appreciate. I know for me, I did start with for example, the ASCE-YMF, and recently started going to being part of the ACE mentorship program and helping the high school students out. And yeah, I think it's great. It is more of a, not only that you're helping out, but it gives you I think a newfound respect or passion for the structural engineering field, on how important the things that we do are, explaining it to the next generation of potential engineers, and kind of gives you a bigger perspective of the stuff that we're doing is really important. And, the industry is giving us a lot. And how do we get back to the next generation of engineers or the current engineers too, for example, in the YMFs and whatnot. So I definitely think that's a huge part of why you got that award. And definitely, I don't think you need to be shy about it,
Yeah, as I said, I think you summarized it really well, but I don't know, I always feel like I'm a work in progress, so you can always improve. Yeah.
Yeah, exactly. And I think that's what's cool about engineers. I think a lot of us don't want to get recognition, but I don't think that's what we need as an industry.
Yeah.
I think we need to pat ourselves in the back more and give each other recognition. So, congrats on that. Not only with the giving back to the community, but all the projects that you've done and the contributions that I think with the Python scripts and whatnot. I think that's huge, and not enough engineers are using it. So, congrats on that.
Yeah, thank you.
What do you think the future of structural engineering is heading for in the next couple of years?
Oh, I'm actually kind of excited to answer this, but also like as an outsider, I feel like there's going to be so many cool things that are going to be happening in the next 10 years. I think there'll be a lot of focus on automation, and I think the biggest thing I'm kind of fascinated by it, how they would leverage like AI and how they can like probably use virtual reality to basically like try to create these augmented models where we don't even have to go to the site, and then we can kind of do a QC just by like being in like a virtual reality room thousands of miles away. So I think there's a lot of focus on automation in addition to AI utilization, and also like there's a lot of focus on how we can make buildings more sustainable, because with the climate change, I feel like we also have a lot of responsibility to be responsible, not just build a building, but see like how we can make it more sustainable. I think those three things I can think of are like the most exciting things that we're going to see maybe in the next 5-6 years, not even 10 years.
Yeah. What do you think the role of the structural engineer is? Because you're familiar with automation, and then you mentioned AI too, that maybe that could lead to more automation. Where do you think the role of the structural engineer is? I guess just my take, it seems like we should still be using it as tools, but instead of needing 10 engineers, maybe you might need 2 in the future, just because I'm envisioning it like the Tony Stark, where he's got his AI, but he's a one-man team designing something really complex.
Yeah.
What do you see it?
Yeah, that's a really interesting question. And I would say like it's really not simple for me to answer that, because I feel like there'll always be need for structural engineers. Like physically, they do need engineers. And I think we kind of like will be responsible for actually feeding all of these engineering like principles into these virtual realities or automation. So the way I see it is like we are like primary, like we will still play the primary role in order to get this implemented, but with the additional help of maybe a programmer or someone who's into virtual reality. So it still has to go through us. And I feel like it could also be possible that there might be some engineers who might actually learn about programming or try to delve into this whole world of virtual reality. Because as you said, if we can comprehend ACI codes and all these complicated design guides, I think it's not going to be a leap of faith for us to just switch into programming or use programming in conjunction with structural engineer. So we will still be that primary like individual who will be responsible for implementing it.
Yeah, because they're at the end of the day, there still needs to be someone that needs to stamp those drawings, right?
Yeah. Oh, stamping the drawings. Yeah.
Someone needs to stamp those, and in the end too, I feel like even with the construction support part of it too, I don't really see that going away anytime soon in terms of, I hope it's, I'm guessing contractors would hate to call us up and they're building their project, they got a construction question, and then they have a AI talk to them or a robot, kind of like a customer service call.
Yeah.
they would definitely, I don't think we're going to be there yet. I think that
Yeah.
I mean, I think the construction support part is where a lot of the human interaction comes in, where you're communicating with the field and to humans. I think the AI stuff and automation could definitely help us out in design. But yeah, talking to the clients, explaining what the design is and in human terms, I still think there's going to be that human aspect of it where, I mean, that's a big part of our jobs, communicating our designs to the clients, to the field, to the architects. And I think we'll have a lot of tools that can help us design faster, more efficiently. And yeah, I still think hopefully we're still going to have the need for engineers and all that in the future. I don't think that's going anytime soon.
Yeah, I agree. I think you put it nicely. Yeah.
Do you have any final piece of advice for structural engineers who are eager to make a significant impact in the field of structural engineering?
Yeah, I think there are a couple of things I can think of. Like, if you're doing your job well, I feel like you yourself are like making an impact. It may not feel that way, but think if we want to talk about some tangible like advice, I would say like if we're just try to be up to date with all the industry advancements, and also like try to seek like diverse project experience, and the last one is like a biggest thing that I'm a big proponent of is like document all your lessons learned, and this will help us avoid mistakes. But at the same time, once you're doing all of these three things, staying up to date and like seeking project experience and documenting lessons learned to avoid mistakes and stuff, I feel like there's a way you have to like share this knowledge with the community. And I think I can think of like engineering tips as like, it's a great, fantastic resource where there's a lot of like really cool, like nerdy engineers like chat like different brilliant ideas. So as I said, like probably trying to get involved with the local community of ASC chapter, try to mentor people is the best way you can create an impact, especially for kids like who are aspiring individuals. And as I said, be an active member and try to help someone out on any forum. They might have a question about a beam that might be intimidating for you, but or might be intimidating for them, but it's probably very simple for you. Just you sharing your knowledge for a minute would probably like you wouldn't realize it, but it's probably helping a lot of individuals out there.
Yeah, I think that's huge advice. It's helping others out and contributing to the community, I think, is one of the biggest things that people don't often realize. That I think you said it nicely, where if you can help people out, you don't know the impact that you're making, but it makes a big impact. Maybe they just might change their view on the industry or want to get into in the industry because you help them out. And I think it's just a great way to help your career as well, because you're going to be learning things as you're teaching them.
Agree. Yeah.
Santosh, thanks so much for joining us. I really enjoyed talking about this type of things, and you helping me learn about Python as well.
Oh,
so I really appreciate it.
Yeah. Last words, like if anything, you actually helped me out. A couple of your videos actually helped me out and made me feel better as being an engineer. So I just want to thank you as well. So as I said, you're impacting a lot of other people out there. So thanks.
Yeah, thanks again. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.